In today's session on data science, a practical guide for beginners. So we will in today's session we will be seeing about data transformation. So what is this data transformation? So this data transformation is nothing but a process of converting or cleansing or structuring the data into the useful format for analysis so as to support the decision taking making process. So whatever is our application, so the data should be suited for it. Okay, so when the data have just been jumbled, but we want it and restructured in the correct way so that we can utilize for our own application. So thus this data transformation is used when the data needs to be converted to match to that of the destination output. Similar to the data wrangling process or data cleaning process, in data transformation also you have 6 steps. That is, initially the data which is obtained, it should be smooth to remove the noises. Then we have to go in for the attribute construction. So this attribute construction, so we have already seen using the combine and the merge command. So we have just taken an example of the data frames of the customer. One is with respect to the details, one is respect to the purchase produced, and we have seen some commands also, inner join, outer join, and we have seen. So how we are enriching the data by using the attribute construction. So the next thing is data generalization. So this also we have seen. Suppose if you have the data, how we are going to divide it into the intervals. So once the data is generalized, then we move on to the data aggregation process. So in this data aggregation process, what you are going to do, you are just going to aggregate the or combine the details as per our application. So then you are going to discretize the thing data, and then you are going to normalize it so that you are going to apply it for our own application. Now here, so if you could see, the first process is a data smoothing process. So as I told, this data smoothing is a process that is used to remove the noise from the data set using some algorithms. So it allows for highlighting the important features present in the data set, and it helps us in predicting the patterns. Okay, so when we are collecting the data, okay, it can be manipulated or eliminate or reduce any variance or any noise which is present in the data. Here if you are going to see the command here, df.smooth, that is you are going to smooth the data frames of sales. It has given df sales dot rolling windows equal to 3 dot mean. So we have a sample data. Okay, a 6 row data is there in which 2 datas are shown as run. Okay, so when 2 datas are shown as none, we are just going to use a rolling window and compute the mean, and then we are going to smooth the data. So which is visually shown here. You have the raw data with spikes. Okay, you are not having a smooth data. Okay, so instead we are going to smooth the data, and the smooth data is shown in red color by using a rolling window frame. So once the data is smooth, then we are going to go in for the attribute construction. So in attribute construction method, the new attributes are going to add it to the existing attributes to construct a new data set. Okay, so these new attributes are created and they are going to apply to the mining process from the given attributes. So this simplifies the original data and it is going to make the mining more efficient. So here it just shows the original data set, that is before the attribute construction, where it just takes 5 student names and the hours they studied and what is their sleep hours, and accordingly the percentage has been calculated. Now we are clearing up with the new data set after the attribute construction. So based on the data which is received, that is student and the hour studied and how much they slept, you can compute the attendance. So based on the attendance percentage, you can also compute their performance score. So that comes under your attribute construction. Then we will move on to the third step, that is data generalization. So data generalization is nothing but it transforms the detailed data into higher level concepts or specified categories. That is, it mainly focuses on grouping the data into broader categories rather than performing the calculation. That is, you are going to replace the individual ages with the age groups, either 20 to 30 or 30 to 40. So just we have taken a pandas code, and here the Python code gives pd.dataframe where the age has been mentioned 23, 35, 29, 42 and 50. Now in this generalization we are just going to make them into groups. Okay, so 20 to 30, 30 to 40 and 40 to 50, for which for segregating we are using a command called pd.cut. And what are the bins, what are the ranges? It is going to be in the intervals lying between 20, 30, 40 and 50. So you have 5 data. So you have the index from 0 to 4 and the given age is been printed here, and you are also going to give a generalization stating that it is going to lie in which range. Once the data generalization is done, then we will move on to the data aggregation. So this data aggregation or data collection is a process in which the data are going to be stored and the data are going to be presented in a summary format. Okay, so these data may be obtained from different sources and you are going to integrate all the data. So this is going to be essentially an important state in computing the accuracy of the data analysis. And if you could see, so it gives an important insight in understanding the quality as well as the quantity of the data used. So here a Python code is taken in which the data is nothing but date, region and the sales. So you have just taken 2 dates. So the sales we are going to consider for the January 1st and 2nd of the last year. So what are the regions you are going to consider? All the 4 directions, that is north, south, east and 3 directions are considered. Then the sales are also are embedded here. Now we go for the code. Df is equal to pd.dataframe, and first thing you are going to aggregate the sales either by region or by date. Okay, for which we are going to write the commands. If I am going to aggregate the value by sales, I gave df.group by region. Sales, I'm going to group the sales with respect to the region, that is north, south and east. What is the total sales that has occurred? So since whenever I'm going to give this data frame, it is going to print out the inputs. Okay, so for the January 1st and January 2nd, corresponding to the regions, what is the sales? Now when I give the command as group by sales by region, so it just relocates the index. So we are giving group by region. So it groups by 3 regions the sales value dot sum. So it has to sum up. See here, 2 north is there, 2 east is there, 2 south is there. It just sums up the value and then it resets the index. It does not have the original index. So it just groups as per the region the sales. Okay, and then it resets the index and gives the value. Thereby the values have been grouped with respect to the region. Next I'm going to aggregate the sales by date. Okay, whatever is our application, so we can write the code accordingly. So when I give this command sales by date, it just takes 2 dates are present, January 1 and January 2, 2024. It just combines and writes all the sales. So data aggregation as per our own application, so we can just extend our code. The next fifth step is a data discretization. When I say it as a data discretization, it is a process of converting the continuous data to a finite set of intervals. Okay, so this process discretization, it just simplifies the data analysis by grouping the similar values. So we have just taken the data frame, data equal to pd dot data frame, and the marks of few people have been mentioned here. Now we are going to discretize. We are going to segregate what? We are going to segregate the marks. So you give the command as pd dot cut. Okay, and what are the ranges you are going to take? The markers from 0 to 100. So I am just putting 4 intervals: 0, 50, 75 and 100, and for which I am labeling as 3 labels. Okay, so suppose 0 to 50 means low, 50 to 75 means medium, 75 to 100 means high. So whenever I'm going to print the data, it is just going to take the index and it is going to present the marks. So this, they are going to be classified as, discretized as 3 labels. So I'm just till 50 it is taken as low, until 75 is going to be taken as medium, and for the remaining value it will be taken as high. Now once, so the data has been discretized, now it is ready for publishing. You can connect it to any API for integration, or you can connect it via a dashboard, or you can store it as a CSV file. So it is depending upon our end application. Now here we are just taken our data of the air quality in Andhra Pradesh area, where we are just including the command SQLite. Okay, so location has been taken: Hyderabad, Vijayawada and Visakhapatnam. We are taking the air quality index also, and which we are going to categorize as moderate, satisfactory, or it is going to be moderate depending upon the value. So now you are going to publish the value as CSV file. Okay, so whenever it is going to be published as a CSV file, you can see the stored data in the SQLite database as location, depending on whether it is going to be Hyderabad, Vijayawada or Visakhapatnam, and the data is going to be published with regard to the air quality index values, and also based on the category of the air quality index present, by which we are going to give the categorized value as moderate or satisfactory. So thus these are the 6 steps in the data transformation. Thank you.